Today we're going to try something different. It's Sunday and I have homework to do. And my homework is I need to get a lab done, and more specifically an OSPF lab using both Cisco and Juniper devices. So I figured, why not share my struggles with YouTube and all of you? And by struggles, I mean learning. So this is what we're going to do, and I'm going to show you how to do it on the fly. Now, the easiest thing that I can say is when you're building a lab, it's easiest to build the diagram first, get your instructions, and then plan your configurations around that. So let's jump right into the lab, shall we? In order to get into this lab, we have first built a topology based on the guidance that we've been given by our professor. And it is an OSPF lab that focuses not only on Cisco, but also Juniper. So it's a multi-vendor environment, and this is exactly what we want. For Cisco, we're using the IOL devices inside of EVE-NG, and for Juniper, we're using the free Junos lab devices that Juniper provides at no cost. And they have been instrumental in learning Juniper and Junos in general. So as we can see here, we do have three areas, area 0, 1, and 2. And for all of you who have watched my OSPF videos, you'll know that there are planning mechanisms that you need to have in place in order to make sure that your multi-area is going to work the way you expect it to. Now, in this setup, it's a pretty small one, so we don't have to worry too much, but rather than talk about it, we're just gonna jump right into it. So I'm gonna show you this. So first and foremost, we have C1 through 3 and J1 through 3, right? You can see the areas, you can see the interfaces that are connected. So what I'm gonna do is actually start from scratch on Cisco. Let me go ahead and make sure that if these aren't fired up, we will get them fired up. It looks like I have actually gone to router 3. So what we'll do, and what we'll do while we let Cisco fire up, is I'm going to show you what Juniper looks like when you first boot it. And this confuses a lot of people, so it's easiest to actually walk you through it. So the first thing that you're going to see is a default login. The default login username is root. And what happens is it's going to log you right in to the Linux shell. And as you can see here, we are root and we are in the Linux shell. The first command that you're going to want to run is CLI, or command line interface. Now, I want you to notice what's up on your screen. This is default behavior for a Junos device. It is configured to reach out to try to upgrade its image via DHCP. And if you notice, it's targeting FXP0, which is the management interface. We don't like these messages, so we are going to go ahead and delete them. So the first thing that you need to do is you need to type CLI. This actually drops you into the command line interface running Junos. So if I did show ver, now this is going to show me you are running Junos. Okay, so we'll control C this. We will write edit, or you can also write configure. They're the same. All right, it's just easier for me to write edit. Now from here, we're going to set a system root authentication plain text password and click enter. We're going to put a password. We're going to retype the password. And then from here, this is the key command, delete chassis auto image upgrade. Now you can see I am tabbing here. It just makes things a lot easier. I'm going to hit enter. And now I have to hit commit. Now, once I hit commit and I've done the previous two commands, I will now have a nice clear terminal with no more of those annoying messages. On Cisco, we don't have to do any of that. So now that told Cisco we don't want to accept the default configuration parameters, which any good network engineer is always going to say no. Now we can actually go into our configuration. Start with C1. We know that E01 has to be an area 1, and we know that E00 needs to be an area 0, right? But let's start with the IP addresses. Now, I know it is somewhat generalist, but we also want to talk subnetting a little bit. So as we can see here, we are using /30 networks. So what we know and can glean from that is we're going to have two usable IP addresses on that network. So if the network address, and we'll start with E00, is 1.0, our first usable is 1.1, and our last usable is 1.2. And then our broadcast address will be 1.3, and the next network will be, you guessed it, 1.4, which is right below it on the next device. So let's go ahead and get these done. So the first thing we're going to do is an enable. We've already done that. Let's get into our global configuration. We'll give it a host name, Cisco 1. Now we'll do our loopback, as we can see. So we can do an int loopback 0, right? and then we'll do an IP add 1.1.101, and we'll issue a /32 address. So now our loopback 0 is up. So now we want to get into int E01. That's going to be our area 1 interface, but we're just doing the IP right now. So let's go ahead and we will do E00. Oh, I'm sorry. Not E01. Let's do E00. Okay, that's better. We'll do an IP add, and then we will do a 192.168.1.1, and then we have to do a /30, so it's going to be a 255.255.255.252. There we go, and we'll go ahead and no shut it. All right, and now we'll go ahead to our E01. Then from here, I know it's a /30, but it's going to be a 1.21, I believe. But in this instance, it's going to be a 1.22. I've already written down my configurations outside of here just to make things easy. Now, I could copy them in, but I want to do them one by one. We can show everyone at home how this goes. We'll do a no shut, and we will do a do write memory. All right. So C1 is done. Let's go. Oh, and as I did that for, I did C1's configuration on C3. Outstanding. All right, let's remedy that. So first things first is we will take C1, since I just did this on your screen, and I will go ahead and paste them here. Okay, so here's C1. Let's do C3 since we just screwed that up. All right, so we'll do a host name C3. Fix that real quick. All right, so now let's do an int loopback 0, and I'll do a no IP add since I screwed that up, and I'll do an IP add, and we can see for C3 it's going to be a 3.3.3.3 /32. All right, now we'll get into interface. For C3, this is going to be, we'll do E00. I'll do a no IP add, and then I will do an IP add for E00 on C3 is going to be a 192.168.1.9 255.255.255.252. All right, and then we'll get into E01 and no IP add. That's how you negate an IP address on an interface, by the way. And I'm doing this in real time and showing you my mistakes so we can troubleshoot on the fly and do it once. So no IP add. Now we'll do an IP add, and this is E01 on C3. So we'll do a 192. Actually, we can do this. Let's do an up arrow here. And we know our IP address from our configs that we're looking at on the side is a 1.6. All right, I think we're good there. We'll do a no shut, do WR, and then just to be sure, I'll do a do show IG in brief, and that all looks good. Same thing here. I'll do a show IP in brief. That all looks good. So let's roll over to Cisco 2. I'll do a conf T. I'll do a host name C2 IP. Let's do an interface loopback 0, and we'll do an IP add for C2 is going to be 2.2.2.2 255.255.255.255. That's a /32. So we're good there. It automatically came up, so we don't have to worry about a no shut. We'll get into int ETH00, and I will do an IP add. This is going to be in the 1.0 range, so we'll do a 192.168.1.2. There we go. And then we'll do a /30. We'll do a no shut. And then we'll get into 01, and we will do an IP add. This is going to be in the 5 range, I believe. So this is going to be 1.5. 5, no shut. We'll write our configs, do show IP in brief. Looks good. Can we ping? We'll do a do ping 192.168.1.1, and then we'll do a 1.6. Everything looks good there. Great. So we do an ARP. Now we'll do a do show ARP, and you can see we do have our neighbors inside of our ARP cache, so we're looking good there. All right, so Cisco should be good for now. I'll pop back over to C1. Now let's move over to Juniper. All right, so let's actually do this the right way so we don't waste time this time. So let's do a set system hostname J1. That makes things easy. All right, now what we're going to do is we have 000 and then 001. All right, so we want to make sure that we target this correctly. So set interfaces, GE. Tabbing is not always going to be your friend on Juniper here before you configure it for the first time. Okay, but we will do a 000. Now, here's the thing. You can do a unit 0 or you can do a .0. It's the logical addressing of the interface. Juniper makes that a little bit easier where they allow multiple logical interfaces on one physical. All right, so you're going to have to identify the unit, or you can put a dot and then the unit number, which in our case right now is 0. So we'll do a family inet, all right, because this is an actual layer 3 interface. We'll do an address, and then we will do for 000, we'll do a 192.168.1.18 because that's we're on this subnet right here. And the cool thing is you can actually do the CIDR notation on Juniper, which makes things a little bit easier. All right, so we'll go ahead and we'll do that. And now we want to do gigabit 001, so we'll just change happy to glad. And then for here, we're going to be in the 1.20 subnet, so that's going to be 1.21. So we'll go ahead and do that. All right, and lastly, we want to do the loopback. So we'll go ahead, we'll just delete this, and we'll do loopback 0, and then you could either do a unit 0, or you could just do a .0, and then we'll do a family inet. And then from here, the address, and our address on J1 is going to be 6.6.6.6, and with the subnet mask or CIDR notation of 32. And we should be good to go. So now we'll do a commit. And after we do our commit here, we're going to go ahead and we'll do a run, which is the equivalent of do on Cisco, show interfaces. And then we'll do terse, which is like show IP in brief. And we will do a gigabit Ethernet with a little asterisk, because that's all we want to see. And as you can see here, both of our interfaces are in fact up. Now, if we wanted to loop back, we'll just change this to loopback. And then we can either do 0 or just do an asterisk. As you can see here, we do have our loopback interface, which is up as well. So we're good to go on Juniper 1. All right, now on Juniper 2. So set system hostname J2. Set interfaces, we'll do a GE 0.0 and family inet. And this will be address and 192.168.1.17/30. Good to go. And then we'll move on to 0001, and then this is going to be a .14, and then last we will do a loopback 0.0 family inet address, and for what is this, J2 is going to be 5, right? 5.5.5.5/32, and that's it for J2. We're good there. We'll commit that and move on to J3. Set system hostname J3. Now, the one thing that we are going to focus on a lot on this channel is automation. And I will tell you that Juniper is very easy to automate. We are going to focus on that quite explicitly in the future. But for now, I really want you to understand how the technology works on the operating systems themselves. And I also want you to be able to actually manipulate the technology and the operating systems on your own without the use of any type of automation. Getting yourself comfortable with a command line interface will make it a lot easier to parse when you're writing automation commands, because you still have to know what the operating system is willing to accept as far as your commands. Okay, so we will do a family inet, and then for J3, we know this is going to be 1.10.1.10/30. Oh, I forgot address. Yeah, it looks better. All right, now we'll go to 1, and we know this is going to be a 1.13 quick, and then we'll do a loopback. So LO0.0 family inet address, and for J3 is going to be 4.4.4.4/32. We'll hit it with a commit, and we are good to go. All right, so now we've already looked at our interfaces. Now what we'll do is we'll do a run ping. Now, let's see, we're on J3, so let's see if we can hit our loopbacks. Can we hit our loopback? Sure can't, because we don't have any route. We don't have any route, we don't have any routing. We just have statically assigned interfaces. But can we hit our directly connected? So that would be run ping 192.168.1 dot, and let's do J1. J1, we're not going to be able to hit that either, but we should be able to hit J2. So J2 on gig 001 is going to be 14, and we can hit that. Great. All right, so we can hit our directly connected, but we don't have any routes, and that's a problem, which is no big deal at all, because now we have to actually do our routing protocol. This is where we want to do OSPF. So we see we have 3 areas. What is area 0? Our backbone area. Okay, we know that from all the other times we've dealt with OSPF. So what would that make C1 and J1 and area 1? That would make them your area border routers. Same thing with C3 and J3, also area border routers. Okay, just for different areas. Okay, so now, in order to make sure that we can all talk to one another, we have to implement OSPF. So let's do it. So on C1, let's get back into global config. And then what we're going to do is we're going to do a router OSPF 1, process ID of 1. We've seen that before. And what we'll do is we'll assign it a router ID, and we're going to make that router ID the same as our loopback. So 1.1.1.1. All right, associate me and my ID as my loopback interface. You can hit it, you're good. All right, but we have to add our loopback interface or loopback network into the OSPF area. So we'll do a network, and we'll do a 1.1.1.1, and we do a .1 as the network because it's a /32. So we'll do a 0.0.0.0. That's our wildcard for all. And then we'll assign it the area, which is going to be area 0. The next is going to be our area 0, which is also going to be 192.168.1.0. And then from here, this is a /30. So this is going to look a little bit different as a wildcard. It'll be 0.0.0.3 because that's the inverse. Basically, 255 minus 252 is 3. So that's how we get .3. And then we're going to assign that to area 0. And then lastly, we have our final area 1, and that network is going to be 1.20, and it will also be a wildcard of 0.0.0.3 because it's still a /30 network. So we're looking good there. We'll go ahead and commit that, and then if we do a do show IP protocols, we can now see that OSPF is in fact running. All right, and our router ID has been committed, and what this says is it is, in fact, an area border router. Why is that? Because we gave it 2 areas. So it knows what it's doing. It knows, okay, I have an interface that's in area 0, and I have one that's in area 1. Therefore, I must be an area border router. Sounds good. All right, let's move on to C2. So global config, here we go. Router OSPF 1. Let's do a router ID. We're just going strictly loopbacks here. Make it super easy. 2.2.2.2. Now let's add the network. 2.2.2.2. Let's give it the wildcard of a /32. And we will put this in what? Area 0. Because that's where it is, according to our diagram. All right, now let's do a 192.168. And then we'll just do a 1.0. And we'll give it the inverse of the /30. And this is also area 0. Now I can already tell you, this is going to identify itself as a certain type of router. So we'll do a 1.4. We'll go ahead and give it a wildcard, which is /30. And then lastly, and here's the delineation, ding, ding, area 0. We'll go ahead and write our changes. And if we do a do show IP protocols, we're going to notice that OSPF is here. You notice it doesn't identify itself as a border router, correct? Why is that? Because it's only in area 0. So therefore, this is going to know this router is a backbone router, all right? And you can see that number of areas in this router is 1, right? That's going to identify itself as a backbone router. Okay, wonderful. Cisco 2 is done. Let's move on to C3, which is going to be an area border router. So we'll go ahead and get into global config here. So router OSPF 1, router ID is 3.3.3.3. We'll do a network 3.3.3.3. Give it the wildcard area 0. So that's our backbone area right there. Now we'll do a network 192.168.1.4. Yep, that's going to be an area 8. Let's give it the wildcard /30 area 0. Looks good. All right, and then the last is going to be our internal area, right? So that's going to be area 2, and then we'll go ahead and we'll list this at 1.8. All right, and I am actually missing a subnet on the bottom here. How dare me? But that's okay, because we already know what it is, because we're missing the in-between here. Let's actually do this on the fly. So what would this be? Since we can see that we're missing this right here. So we have 1.4 as our network address. So 5 and 6 are usable. 7 is our broadcast. So logically speaking, 8 is going to be our next address. All right. Now, let's go ahead and we will write our changes, and we will do a do show IP protocol. And I can already tell you that the router is already telling itself, yep, you are a border router, buddy. Looks good. Okay, great. Now, what about our neighborships? Do show IP OSPF neighbor. And you can see that it has formed a neighborship with 2.2.2.2. So we are looking good. Now, can we ping it? Sure can. What about router 1? Yep, sure can. All right, we're looking good. But obviously, we have no OSPF paths over to our Juniper side. So now, this is where it gets fun. This is where we actually have to make vendors talk to one another, which can be intimidating, I know, but we're going to make it happen. All right, so the first thing that we're going to do is we're going to set routing options, and we'll do a router ID. All right, now here's the thing. Sometimes you don't even have to tab. If it's the only command that's available, you just hit the space bar, it's going to finish your statement for you. So you always want to check it to make sure you're not putting anything you're not intending to, but it's actually makes things nice and easy. All right, so let's go ahead and give it a router ID. We know loopback addresses J1 6.6.6.6. All right, so that looks good. Now let's talk protocols. Set protocols, easy peasy. OSPF area. Now here's the key. We're not doing area 0 like Cisco. We're doing area a lot of zeros, which can get confusing because it almost looks like a wildcard, but you don't have to worry about it because Juniper's not going to ask you for a wildcard. It's not going to even ask you for a network. It's just going to ask you for an interface. All right, so let's do a loopback 0, right? .0. Make sure you give it the full. And then what we're going to tell it is we want our loopbacks participating, but we want them to be passive. Okay, you don't have to do this in Cisco. Cisco automatically assumes that your loopback's going to be passive inside of these OSPF networks. But in Juniper, we're going to be explicit. Right now, from here, we're going to go back. We'll do another area 0 entry, but instead of loopback, we're going to do GE 0, 0, 0, a lot of zeros, .0. Looks good. And lastly, since this is J1, we know that's an area 1. So let's go ahead and we'll change this to a 1, which is our interface. And lastly, let's go ahead and change our area to 1. Easy day. Commit. That looks good. All right. Now, if we wanted to, we could do something to the effect of run show configuration and then do a display set, and then we'll do a match OSPF. And you can see these are the commands we just ran. All right, let's move on. We're talking too much. J2. All right, we're already in configure mode. So let's go ahead, set routing options, router ID, and then we'll go ahead for J2. That's going to be 5.5.5.5. All right, set protocols, OSPF, area 0.0.0.0, and then we'll do an interface loopback 0.0 passive, just like the other one. we'll go ahead and we will stick to this. We'll do an interface, and then we'll do a GE 0.0.0.0.0, and that's going to be inside of our area 0. This one's easy because J2 is strictly area 0, so we're good there. And then lastly, we'll do area 1 and commit. All right, last one, J3, and you see the gist now. So what I'm going to do is just speed this along a little bit. Now that we have seen how this works, and we'll go ahead and commit. All right, awesome. All right, now what we should do, let's go back to C1. We are fully configured now for OSPF. So when we do a show IP OSPF neighbor, all right, you can see now that we have neighborships with both Juniper and Cisco, all right, and they're both full, which is great. All right, C2 should really be the same way. We have a neighborship with router 3 and router 1 because this is a backbone router, which is great. And in C3, we should see the same. We have a neighborship between both J3 and C2, which is beautiful, right? And we're full on both, which is exactly what we want to see, right? Juniper is the same way. It's a little bit of a different command, but what we're going to do is I'm going to go ahead and exit, so I'm in operational mode now. And what I'll do is I'll just do a show OSPF, and we'll do a neighbor, right? And as we can see here, it's the same thing, all right? You can still see the interface that it's on. You can see the address, and you see the router ID plus the full. We want to see how many seconds until our dead timers expire, right? That's a big deal because those are metrics that could actually bite us down the road, all right? But that's exactly what we want to see, all right? So now let's talk about our routes, all right? First and foremost, let's go ahead and try to actually confirm end-to-end. So J3 is 4.4.4, all right? So what about Cisco? Can you ping that address? Can we ping 4.4.4.4? We cannot. All right, that's telling me something. All right, so let's do a show IP rep. And from what I can see here is we do have an intra area for 2.2.2.2, which is here. And that's going to be via our 1.2. So that's going to be C2, which is exactly what we want and expect because 2.2.2.2 is C2. But now we're also seeing the O/IA inter area, which is going to be our 1.8 via our 1.2, which is interesting. All right. So let's go over to J1 and then we'll look at the routing table here as well. So we'll do a show route. So a show route is going to give you INET 0. This is your whole routing table. We're going to do a show route, and you can also do a protocol, and then we'll just do OSPF. All right. Now, we expect all of these remotes, right? So we have 4.4.4.4 and 5.5.5.5. All right. Now, here's the thing. What we aren't seeing is 1.1.1.1 or 2.2.2.2. So we're actually missing some routes here. So one thing that we are missing here is we're going to have a discontiguous area 0, which basically means that none of our routes are going to propagate properly. So what we need to do is actually bridge a connection in area 0 between C2 and J2. So let's do that real quick. Our last right here is going to be a 1.20. So let's go ahead and make this a 1.24. Roger that. Now we'll go ahead and implement these configurations on C2. So in order to do this, lastly, we'll get into int 02, and we'll do an IP add 192.168.1.25, and then we'll give it a /30 net. We'll do a no shut, and then real quick, we'll throw this into OSPF. So we'll go ahead to router OSPF 1, and then we'll do a network 192.168.1.24 wildcard of 30, and then we will put this in area 0. And we will write our changes, and then lastly, let's do this on J2. So we'll get into edit mode, and we will get interfaces GE 0, and you see how this taps now because I already made some configs on gigabit Ethernet interfaces. 2 unit 0 family INET address 192.168.1.26, I think, /30. All right, looks good. And then we'll go ahead and set protocols, and we will do an OSPF area. We'll make sure we're in area 0, interface GE002.0. We'll commit this. And now, once we do this, let's go ahead and actually look for a route here. So before we were not able to ping 1.1.1.1, which is C1's loopback. So let's do a show route. Now we actually have a route to it, and it's routing through J2. It's routing through there because it's going through its backbone, all right, which makes sense because 1.1.1.1 is in area 0, so it's following its metrics. That makes sense. So before we did have a discontiguous area 0, that's why we were all jacked up, all right? But everything is looking good here. So let's just do from here, and before we were checking our databases, we were noticing that our summary net link states from area 1 were propagating just fine. And that was a good thing. And our area 0 was giving me everything I needed as far as my loopback and router IDs, but that's gonna change now. If we look in our database, okay, so now we can see it inside of our area 0, our actual link states have everything to it. Okay, that's what we want because C1 is an area border router, so it should know about everything. It's going to issue those networks as it sees fit. So we're looking good here now. So now if we go ahead and do a ping 4.4.4 and we'll source it from our own loopback, we're good to go. A packet leaves Cisco a loopback in area 1, which we just did for C1 to J3. It crossed the area 0 backbone, it hopped through the Juniper ABR into area 2, and then came back. All right, so this is 2 vendors, 3 areas, and 0 static routes. So if you caught my multi-area OSPF video, that is a lesson in the real world because you have to remember what we talked about. Every non-backbone area has to touch area 0, which we can see here in our configuration. The area border routers sit on the seam and translate between areas with a type 3 LSAs, which is exactly what happened here. And that's what we were missing, unfortunately. Router IDs have to be unique, and loopbacks will make that deterministic. We just did that here in real time. And that's literally what you watched me build. C1 and J1 are in the area 0 and area 1 as ABRs. C3 and J3, area 0, area 2 ABRs, and C2, J2 are pure backbone. The theory maps 1-to-1 to the config. So here's where the vendors diverge and where students usually trip up. For Cisco uses the network statements and the wildcard max, and you saw me do that real time. The interface is implicit as far as the loopback. For Juniper, it puts the interface directly into the area. There's no wildcards you have to worry about, no network statements. The area owns the interface. Now, Cisco, you can do that too, but in normal configs where you see OSPF being implemented, you'll see network statements. All right. Area notation, Cisco accepts area 1, whereas Juniper wants 0.0.0.1, dotted decimal always. Loopback being passive, Juniper explicitly have to mark the loopback as passive under the area, and Cisco just pulls it in with a host mask network statement. So different syntax, same protocol. OSPF doesn't care what's printing the LSA as long as the area ID and the hello parameters match, they become neighbors. And we saw that here with Cisco and Juniper. All right. 2-letter codes as far as what to look for. We'll go ahead and do a show IP route OSPF. And 2 codes to look for, you're going to see your O, which is your intra area, right? And then you'll see your OIA, which is your inter area, which means that it crossed an ABR to get here, right? And you can see here, if we looked at this and you saw 1.8, you can see that's down here for C3 and J3. So it had to cross an area in order to get here, right? And that's what we want to see. So on C1, you'll see the other area 1 and area 0 loopbacks is O, and everything from area 2 is OIA, right? Now, on Juniper, it's a little bit different. So we'll go ahead and we'll run show route protocol OSPF. We did this before. I love Juniper's routing tables. They're just so much easier to read. So why the lab kind of matters. It's a 5-minute config if you do it fast. But the reason a professor puts Cisco and Juniper in the same topology is because the real world looks like this. Nobody runs a single vendor network anymore. You'll sit down on a job where an OSPF adjacency is bouncing between Cisco and Juniper. And the first fix is going to be exactly what we just did. Verify the area, verify the router ID, verify the interface is actually in the protocol. In our case, verify that you don't have a missing statement as far as like an area 0 connection, right? So that ended up becoming a thing. So that's lab 8. So I'm going to put these configs on GitHub, and that will be in the link in the description. If you haven't seen the multi-area OSPF deep dive yet, that's the video that explains the why behind everything I just did. So you should watch that one next. So subscribe if you are on the network automation path, because we are going to be automating this stuff, because we are building this channel to get you from CCNA, JNCIA to running multi-vendor automation for real and actually doing it efficiently, right? So join me on this path. I'm super pumped to get this going, and I will catch you in the next one.